So hello, today we are going to learn the new chapter, which is the second chapter from physics, work, energy and power. So today we are going to learn the chapter whose name is work, energy and power. So first of all, what is a work? So work is said to be done only when the force is applied on a body. If any force is applied on a body, and so it is said to be that the work is done by a person on that object. So whenever a force is applied on a body, it is said to be that the work is done. So what are the main factors on which the work depends? First of all, magnitude of force applied, and second one, displacement. So this is the formula for work done: force into distance. So work is a scalar quantity. This is also the main point to be noted, that the work is a scalar quantity. So first of all, what is the meaning of the word scalar? Scalar quantity means the quantity which has no sense of direction. No sense of direction means it doesn't consider the direction. Distance is a scalar quantity. Displacement is a vector quantity. So we are writing this work equal to F into S. So this equal to denotes that the work is a multiplication. This is the scalar multiplication. So here work done by a constant force. Now the second point is that when the force is applied and work done is in different direction. So for suppose that work is applied in this direction and the object is moving in this direction, so there will be angle created between the work done and the force applied. Okay, so let us move for the next. So at that case, what we will do, we will find like this. So consider this, we are applying here, this is inclined plane, the work is being done, so this will be considered, this like the angle will be created. So this side we will call it as hypotenuse, this one we will call it as a base. So let us consider the base as S. So what is cos theta? Cos theta equal to base by hypotenuse. So what is base? S by h. So S equal to cos theta into S. So this is the formula for the work done when finding force along with the displacement. So work equal to force into S cos theta. So now when the finding the force, so that time the formula will change like this: work equal to F cos theta into S. F cos theta into S. Next, what are the conditions for work done to be zero? So when the work will done will be zero, when there will be no displacement. So initial final minus initial. So when there will be no displacement, then the work is said to be zero. When the displacement is normal means at 90 degree. So we know very well, when there will be 90 degree, cos 90 is equal to 0. So when we will multiply f anything with 0, the work done will be 0. So when the work done by the force of gravity, for the work object is falling down, so when the work done by the force gravity, then we will consider, if we can write as mg, mass due to gravity, and next h, for the height we will write as h. So this is the formula will be created, mgh. This is also the formula for potential energy. So what are the units of work? First of all, work equal to force into displacement, which is the Newton meter, as it is also a unit of moment of force. As it is unit of moment of force. So to make a difference between the work and the moment of a force, the SI unit of work is joule. So the SI unit of work is what? Joule. So it is nothing but we can say that 1 joule is equal to 1 Newton meter. Next, CGS unit. So in that we have learned the CGS unit for moment of a force, that was dyne centimeter. But here what is erg? ERG, erg. and 1 joule equal to 10 power 7 erg. Next, work can be calculated. Work done equal to constant force. A constant force into displacement moved in the direction of a force. The distance covered in the direction of force. So, as a unit of work is joule. You know why this symbol is J capital, and for the Newton the symbol is in capital. I have told in that. So that video also you can see properly, because to honor a scientist, the scientist name, the symbol of a unit is given as capital. So next, what is power? Next topic is what is power. So the power is nothing but the rate of doing work. So what is the meaning of rate of doing work? Means work done per unit time. Work done in a per unit time. So that is called power. And power equal to work done by time taken. So what is this unit? It is measured in watt. CGS unit is erg per second. So this is the CGS unit of power. Next, 1 watt equal to 1 joule per second. 1 watt is equal to 1 joule per second. So what is a power? Power is defined as the rate of transfer of energy or work done. Power equal to energy transferred or by time taken or work done by time taken. So we can say that 1 watt is equal to work done by time taken. So what is the unit of work? Joule. What is the unit for time taken? Second. So 1 watt is equal to 1 joule per second. This one we can find here. 1 watt equal to 1 joule per second. Next, what is 1 kilowatt? Kilo means 1000. So 1 kilowatt equal to 1000 watt. Mega means 1000 into 1000 means 10 power 6 watt. Okay, next, energy. What is energy? We are very much familiar with this word energy as we are learning from the smaller classes. It is nothing but the capacity to do work. How much work you can do, the capacity to do work in as energy. SI unit is joule. So for any kind of energy, whether it is a mechanical energy, whether it is any type of energy, the SI unit will be the common unit for them is joule. But to make only difference, we are using another type of units, but the only one common unit for all form of energy is joule. So what is the CGS unit? Now only we learn erg. So 1 watt hour. 1 watt hour is equal to 3600 joule, or we can say that 3.6 kilojoule. 1 kilowatt hour means 3.6 into 1000, we will get 3600 joule into 1000 means 3.6 into 10 power 6 megajoule. Next, 1 electron volt. 1 electron volt equal to how much charge? 1.6 into 10 power minus 19. Next, what is heat energy? So heat energy is measured using one particular unit called calorie. So first of all, the unit of energy is joule. We know very well. So you have a doubt. What doubt? That the unit for heat energy should also be joule only, like calorie. So to give a specific unit for each form of energy, we are using the different units, but the only one common unit is for all form of energy is joule. But to identify it in a proper way, the particular specific unit, we are giving the other different names of the unit. Okay, so 1 calorie. First, what is the calorie? Means the amount of heat requires to raise the temperature of how many gram of water? Only 1 gram of water by 1 degree Celsius. So to raise the temperature of how much volume of water? 1 gram of water for 1 degree Celsius by 1 degree Celsius, that is called calorie. It is the amount of temperature required for raising the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. What is the unit? Calorie. So next we are going to learn about the potential energy. First of all, what do you know about potential energy? Energy possessed when the object is in rest. So energy possessed when object is in rest. For example, water stored in a dam or in a tank. So there are many types of potential energy, as well as we must know first what is kinetic energy. What is kinetic energy? Means energy possessed when the object is in motion, just opposite of potential energy. When the object is in motion, it is said kinetic energy, and when the object is in rest, it is called potential energy. And there are many types of kinetic energy. Rotational kinetic energy. When an object rotates, so suppose the object is rotating, so this will have which kinetic energy? First of all, it is in motion. It is in motion, so definitely it will have kinetic energy. And it is rotating, so which? Rotational kinetic energy. For example, now it is vibrating. Vibrating means somewhat it will be like this. Suppose that it is not a pure circle, it is in vibrating motion. It is vibrating, the object is vibrating, so it will possess which? First of all, it is in motion, so kinetic energy, but it is vibrating, so vibrational kinetic energy. Next, the important topic is work energy theorem. So what is work energy theorem? So work energy theorem says that the final kinetic energy minus initial kinetic energy. So what is the formula of final kinetic energy? Half mv square. For initial, half mu square. So when you will minus this, let us perform this. Half mv square minus half mu square. Alright. So what here we will do? Half is common. Right. M is common. So half m v square minus u square. So what we will get in is final minus initial. So we will get this half mv square. So this is the formula for what? This is the formula. This is the formula for kinetic energy. This is the formula of kinetic energy, half mv square. Okay, next. So this is only the work energy theorem, that half in final kinetic energy minus initial kinetic energy is nothing but the work done. So work done equal to final kinetic energy minus initial kinetic energy. Okay, next, what is the law of energy? First law says that energy can neither be created nor be destroyed. So what is the first form? Energy can neither be created nor be destroyed. And the second point is energy can transform. This the word is very important. Transform from one form to another. How we can say that heat energy changes to chemical energy, light energy changes to chemical energy, mechanical energy changes to, suppose that, light energy. So this is from one form to another form. So this changes from one form to another form. This can be done. It cannot be created nor be destroyed, but it can convert from one form into the another form. It will interchange. And one thing we have not learned here is type of potential energy. We have seen about kinetic energy, but types of potential energy. So there are two types of potential energy. First one is gravitational potential energy. Gravitational potential energy. This is determined by the weight. So this is determined by weight. Gravitational potential energy. And this one, second is elastic potential energy. Elastic potential energy. It depends upon two factors, shape and size. So what is mean by elasticity? Elastic means if object will return back at its same positions. For we are stretching a rubber band, so once it goes again it will come. For example, spring, so it will return back into its same position. That is called elastic potential energy. So other thing, what are the other things? Transformation of energy, how it changes from one form of energy to another form of energy, as well as conservation of energy. What is meaning of conservation? Saving, how we can save energy, how we can save energy from being wasted. So this we will discuss in the next video, in the upcoming video. So let us have a quick recap what we have learned today. So first of all, we have seen what is a work. Work is said to be done only if force is applied on a body. And second thing is the factor on which the work depends, magnitude of force as well as displacement. We have seen the formula for work done equal to force into displacement, and we have seen that work is a scalar quantity. And also we know that when the force is applied and work done, both are in different directions, so then one angle is created between them. What is created between them? An angle is created between them. So when an angle is created between them, what formula we have to use? This formula, work equal to F into S cos theta. And when finding the force along the displacement, we will use this formula, work equal to F cos theta by S. So suppose this is a right angle triangle. Okay, suppose this is a right angle triangle. So this is one angle, this is 90-degree angle. So this is hypotenuse, this is base. So we will use this formula, that we know that cos theta equal to hypotenuse by base. And then we have learned the conditions when the work done will be zero. First of all, when there will be no displacement, and when the displacement is normal to direction of, means normal means 90 degrees. So what is the value of cos 90? 0. So anything work done will be equal to F, what is displacement, S cos theta will be 0. So F into 0, anything multiplied by 0 will be, the answer will be 0. Next we have seen the unit of work, F into S. SI unit is joule and CGS unit is erg. So 1 joule is equal to how much? 10 power 7 erg. Okay, then we have seen the power. The rate of doing work is called power. So power equal to work done by time taken for the particular work to be done. What is the unit of power? Watt. CGS unit is erg power second. So 1 watt is equal to 1 joule per second or 10 power erg per second. So what is power? The rate of doing of work done by time taken. Okay, so what is energy? Energy is the capacity to do work. Unit of energy is joule. CGS unit is erg. 1 watt hour equal to 3.6 kilojoule. 1 kilowatt hour equal to 3.6 into 10 power 6 megajoule. 1 electron volt equal to 1.6 into 10 power minus 19. This is the charge for electron. What is heat energy? Heat energy is the sensation of warmth. So what is the unit for measure the heat energy? Calorie. Very good. 1 calorie equal to 4.184 joule. Next we have seen the rotational kinetic energy. When the object will rotate in a circular path, it is said to have which kinetic energy? Rotational kinetic energy. When the object will vibrate, it is said to be in which motion? Vibrational kinetic energy. It will possess which kinetic energy? Vibrational kinetic energy. And then we have learned the work energy theorem. What does the work energy theorem? Says that the final kinetic energy minus initial kinetic energy will give you the answer of work done. What is law of energy? Energy can neither be created nor be destroyed, but what it can be done, only transferred from one form to another form. So that's all for today.